Okay, so as we said before, some of the scripts in this project are pre-written. So the main camera is the camera that we're viewing our game at. If I zoom out right now, you can see that the main camera is sitting behind the character. And what we want to do is to set that up slightly differently. Currently, by default, when you make a new camera in Unity, you're making a perspective 3D camera. We want to make an isometric view, and because of that, we're going to use orthographic cameras. So the first thing we're going to do is to set up where the camera is positioned. We're going to select our main camera in the hierarchy, and in the transform component, we're going to set the position to 1, 15, minus 22. We're going to set the rotation to 30, 0, 0. Then in the camera component, we're going to set the projection mode from perspective using the drop-down to orthographic. And finally, the size value that then appears to 4.5. And when you look at your scene view, your game view, you should see that you have an orthographic view. Then, a couple more camera settings. We're going to set our background to black. So when you move over to the front of the level, you will see the background color of the camera. We don't want it to be blue. So in our camera component, we're going to click on the color block next to the word background. That's going to open up a color picker, which looks like this. We're going to set this to black, so drag it all the way down to the bottom of the colors and close that panel. Then we're going to save our scene just to make sure it's up to date. And in the scripts folder, we're going to select camera. So this time we are going to create one more script. This script is a lot shorter than our player movement and quite simple. So whenever you select a folder in your assets, so for example, we are selecting camera in the scripts folder right now, we can go to the create button and choose C# script. And it's going to create something called new behavior script. When you create a script, especially in C#, it's very important that you name it accurately. We're going to call this camera follow, so don't have any spaces in your file names for scripts, and try to name them in this capitalized style, capital C, capital F, camera follow.
Quick note on creating scripts like this. If you created it and then accidentally clicked off so it was briefly new behavior, then the class that it makes will be called new behavior. Yes. So you'll need to rename that when you open it.
So if I look at this one that I've correctly named now camera follow, you can see that it's written into the script for me, public class camera follow. And what you'll see is that when you open it up in Unity and switch back, Unity will say class name does not match file name. So you need to make sure that everything in that class is named the same as the actual file, your camera follow script. So once you've named that, click open to open it up in Mono Develop. And you should see something like this. What we're going to do is first off, you get start and update in your script whenever you make a new script. But we don't want those there. So we're going to select over that code, making sure not to select the final curly bracket. We're going to hit backspace just to remove it. So we've got public class camera follow and the open and close curly braces. That's all that we need to begin with.
Okay, so as usual, we're going to start with the public variables at the top. So those are the ones that can be accessed through the inspector or through other scripts. So start off, we need to have a target for this camera to follow. So we're going to make a public transform called target. Next, we're going to make a public float called smoothing. And we're going to give that a default value of 5. So basically, our camera's going to follow the player around, but we don't want it to be super sharp. We're going to give it a little bit of lag, a little bit, just to make it a bit smoother for the player to see. So that value there is going to be how smooth it is. Lastly, we're going to make a private variable called offset. So we're going to store the offset of the camera from the player, like the distance between them at the start of the script. What we need to do is store that, so in each update we can make sure that we have the same offset. So let's store that offset now in start. Offset is the vector from the camera to the player, so that's transform.position minus target.position.
So we're going to apply this script, once we finish writing it, to the camera. So we need to make sure that the transform position, so the position of the camera is subtracted from the target position, the position of the player. So we're going to drag and drop. Because target's a public variable, we're going to drag and drop the player game object onto this transform target, and you'll see that in a minute.
So that's the end of our start function. We just needed to create that offset. Now in fixed update, so remember this is following every physics step, and we're going to use fixed update to move the camera because we're following a physics object. If we used update, then it would be moving in different time to the player because the player is moving in fixed update. So we're going to use fixed update to move the camera, and we need a target position for this camera to try and reach. Target position is going to be the position of the target plus this offset. So we're trying to find a place for this camera to be up above the level, and that's the position of the player plus this offset that we've stored. And now we need to actually move the camera. We're going to do that using a lerp. So a lerp just smoothly moves between two positions. So you get that through vector3.lerp. The position that we want to move it to is between its current position, so transform.position, and this target position that we've just made. So what that's doing is it's saying, I've got my current position and the position I want to be. I'm going to try and move a little bit towards that. That's what this function is doing. So we've got the two vectors that we need to move between. Now we need to tell it how fast we're going to do that, and we're doing that using our smoothing variable that we stored earlier. And naturally, since we don't want it to do it 50 times a second, we're going to times by time.delta time. And that's the end of the script. Very simple.
So for those of you who are ready, what I want you to do is in the Unity editor, select camera follow and drag and drop this onto main camera. So from the project panel, drop it onto main camera. When you've done that and select main camera in the hierarchy, so you should see this camera follow script that I have in the lower right. You'll see that the public variables target and smoothing appear as things that we can assign to in the interface. So target is looking for something called a transform, and smoothing is a number that we can change to whatever we want. Then what we're going to do is to assign the target. The target, of course, is the player, so we just drag and drop player onto the target variable.
Grab the player from the hierarchy and not the scene view. Clicking and dragging the player in the scene view is just going to move the player.
Yep. So one thing you'll notice as well is if you go to click, then drag, you lose the context of the main camera. So select the main camera, then drag and drop player on there. So basically all that's doing is it's finding the game object reference, and then it's finding the exact thing that it wants. It wants to find the transform. Then we're going to save, and then finally we're going to save our player as a prefab. So like I said before, when we introduced the environment was saved as a prefab because we've already assigned a bunch of components to it. So if you've got something set up the way you want it, and you want to save it into the project, so we might want to use the player in other levels of the game, so we save it as a prefab. And the way that you can do that is just to drag it anywhere into the project. We happen to have a prefabs folder, but you don't need to drag it into there, but we'd like you to. So player, drag and drop from the hierarchy and drop it into the prefabs folder in the project.
If you turn it into a prefab, it's an asset, it's a hard drive file. You can save, export it, reuse it all over the place, and then, so there's more benefits to turn things into prefabs.
So I want you to save your scene right now and press play, and you should have a little character that runs around, and you can move the camera, should be tracking him. And we'll show you what that looks like right now. So you should be seeing this. Camera's now tracking around, and we can rotate like this.